Sathyabama Institute of Science and Technology.
Hi everyone, this is Ms. Rajapriya SP from Sathyabama Institute of Science and Technology, Department CSC. The topic for today is round-robin scheduling in CPU scheduling. This is the small introduction about round-robin scheduling. Round-robin is a preemptive scheduling, that is, the CPU will be given a proper time for each and every process, and in this we are using the concept of time slice. Time slice is nothing but a specific amount of time which will be given for each and every process. And the first process is, here we're gonna give every process into the ready queue. That is, each and every process when it is ready will get into the ready queue, and then the first process which is in the ready queue will be executed first, and after the execution is completed in the first process, then the process will be removed from the ready queue, and then the next process will be added to the ready queue. This is, first one is burst time. This is the time required for the process, and the second one is arrival time, and the arrival time in which the process will be arrived for to the execution, and the next one is completion time, in which the process will get completed, and the next one is turnaround time. This is the time interval between the arrival time and the completion time, and the next one is waiting time. This is the time which the process will wait for the CPU inside the ready queue. This is an example. Using this example, we can able to understand the round robin scheduling thoroughly. And in this example, we are having a time slice of 4 seconds, that is 4 milliseconds, and these are the process, that is process 1, 2, 3, 4 and 5, and this is the arrival time for each and every process, and that is the burst time. That is, the burst time is the needed amount of time for each and every process to complete its execution. So for the process 1, it has arrived at time 0. Now the clock is set to time 0. Each and every time the clock will be starting from time 0. That is, when starting a process, when CPU starts its execution, it will start from the clock time 0. And now at time 0, the process 1 has arrived, and so inside the ready queue, the process 1 is present. Now after it's getting into the ready queue, the CPU time will be given. CPU time will be given for the process 1. So it starts from 0, and after the time clock changes to 1, the process 2 also will enter into the ready queue, as the arrival time of process 2 is 1. So in the time clock of 1, the process 2 also will get into the ready queue, but it will not get the CPU time now, as we are given the time slice as 4. Process 1 will execute it till time 4. In time 2 also, the process P1 will get executed, as P3 is not enter the ready queue still, because the arrival time for P3 is 3. So only when the clock time changes to 3, the next process will get entered into the ready queue. Now the clock time has changed to 3, so the process P3 has entered into the ready queue, but still the process 1 is keep on executing inside the CPU. After the time 4, the process P1 will complete its execution, and the process P2 will get the CPU time. The next process P1 will get inside the ready queue, as it has not completed the proper execution. It has some remaining time of 4. So it again get into the ready queue, and it waits for the CPU time. That is, after getting into the CPU from the ready queue, the process will be removed. So each and every process, that is the P1 and P2, will be removed in the ready queue, and now we are having P3, P1 and P4. As the clock time is 5, the process P4 has entered into the ready queue. Now in the Gantt chart, P1 has completed its time slice and P2 is running now, and P2 will run for 4 milliseconds, and the time is 6. After time 6 also, the P2 will get executed, and time 7 also P2 will get executed. At time 6, we are getting the process P5 inside the ready queue. Next, the clock seconds of 8, the process P2 will complete its execution, as it takes 4 milliseconds, as it gives 4 milliseconds for each and every process. P2 will take 4 milliseconds for its execution, and it has some remaining time of 2 milliseconds left, and it will be again added to the ready queue. And in the clock time of 11, P3 will complete its execution, as it needs only 3 milliseconds for its full complete execution. So it totally completes its execution, and now it doesn't have any remaining time. So P3 will not be added into the ready queue again. So the next process will come for the execution. And now inside the ready queue, we had P1 after P3. So P1 will come for execution, and it takes 4 milliseconds to complete its whole execution, and it will complete the execution, and the next process P4 will come for execution, and P4 will be removed from the ready queue. And the next process is P5. P5 will come for execution, and for P5 the burst time is 4 milliseconds. So within the given millisecond it completes its execution and it gives the CPU for the next process which is waiting in the ready queue, that is P2. After P5 is completed in the milliseconds of 21, and P2 will get the CPU, and P2 will complete its process in milliseconds of 23. This is the calculation for turnaround time and waiting time. Turnaround time is the time interval between arrival time and the completion time, and waiting time is the time between which is the time waiting for the CPU. The process will wait for the CPU, that is called waiting time. And here this is the calculation. The completion time, we have to calculate the turnaround time and waiting time from the last, not from the first. For calculating turnaround time for the P1, we have to calculate from the last. From last, P1 is in the place of 15. So 15 minus 0. 0 is the arrival time. So completion time is 15 and arrival time is 0. So the answer will be 15. And for the next one, for P2, in the same way, from the last, if you check for P2, P2 is settled at the last. So it is the completion time of P2 is 23 and the arrival time of P2 is 1. So the answer will be 22. And same wise, it will be calculated for each and every process, and in the waiting time is calculated by turnaround time minus burst time. The turnaround time we have calculated here, that is 15, and burst time is 18, so the answer will be 7. And for the process 2, the turnaround time is 22 and the burst time is 6 and the answer will be 16, and in the same way it will be calculated for each and every process. This is all about round robin scheduling. Thank you.